Howdy AP PreCal, it is Miss Kosh. This is another video on semi-log plots this year. I have some from last year. This is definitely a topic that's tricky for me, so I'm getting better as I go. I also created the notes a little differently than I usually do. So for my kids, and I may put a link to this PDF in the comments, or not the comments, but in the description. That's the word. I was like, what do we call that? The description of the video. So hopefully I'll remember to do that. So what I did, usually I make the notes and then make videos off of it. But this time I made a video here where my kids can take notes on, it's a previous video and they'll take notes here. And then I made a video and decided to incorporate that into the notes. So the second video is here. And now I'm gonna start working the rest of this. And I think there's another page. Yeah, there is another page. And I'm going to work this in this next video. So hopefully I know what I'm doing well enough to convey this to you in a way that makes sense. So watch the first two videos so that this, so that you can follow along a little better. And here we go, starting with this. So you know how AP PreCal loves to give us tables. They give us tables. So let's look at these. Some of this is review. We're going to fly through this part real fast. What we notice here, the input values are increasing linearly and the output values are increasing exponentially. So what type of function is this? This would be an exponential function. Okay, on this one, our input values are increasing exponentially and our output values are increasing linearly. This would be a logarithmic function. That should be, if you're confused by this, go watch old videos because we've talked about this before. What's new to this unit is, well, okay, let's look at this one. Notice linear, this whole thing ends up being linear. Well, we look at this table, you think, oh, well, it's the same situation. We have the exact same numbers. Ms. Kosh, did you really mean to give us two of the exact same table? Well, let me draw your attention to the fact they are not the exact same table. On this one, this is x and this is f of x. So here's just your output values. On this one, they're saying, was it natural log of x? Is that how they wrote it? Oh, now I don't remember. I think I made a mistake. I'll fix this in the PDF below. I think what I want is that this is the natural log of f of x. Okay, and then if that's the case, now I'm not sure. Hang on, you're gonna watch me struggle for just a second. You're not gonna watch me struggle, but I'm going to struggle for just a second and see if I can figure out. I was modeling this off of. Okay. That's what it should have, I'm gonna fix this in the PDF. It should say natural log of f of x. And so, or the natural log of y. So now what happens, we're not just graphing this as input values and output values. This is now the log of the output value. And so when we have a input value that's linear and the log of an output value is linear, well, what would that look like? That would mean that in our semi-log plot, that we've got a linear situation that happens in our semi-log plot, which tells us that this is an exponential function. I'm sorry about the mistake. I will fix that later. Well, it'll look fine for you. So anyway, and so it looked linear, but it's not because we're calling this not the output value, not f of x. We're calling it the natural log. This is the natural log of x. Okay, hopefully not the natural log of x, natural log of f of x. You guys, I'm getting better, but I'm not where I want to be yet. So you and I will keep working together and get better at all this. Okay, so now let's look at this one. I'm asking you to sketch a graph of f of x, and I'm not giving you f of x. So what I'm giving you is I'm giving you input values here for x, and I'm giving you log base 5 of f of x. Okay, so what this is telling us is we'd have to say, well, let's make a new table. I think I need more space. Okay. This was a scavenger hunt we did in class the other day, which has a typo. It should have a parentheses, but whatever. Okay. Here we go. So what I want to do is I'm going to take my x value. I want to figure out. I want to graph my as a function of f. So we'll do our x value. We had 3, 4, 5, and 6. And so, right, yes. And so now what we need to do is we know that log base 5 of f of x is equal to, in this first term, it's equal to 0. Okay, or so maybe what we'll do, let me try that again. Log base 5 of f of 3 because this is when the x value is equal to 3. This is equal to 0. 5 to the 0 is equal to 1. So f of 3 will be equal to 5 to the 0, which is 1. And so we need the point 3, 1. Okay, the next one, we have log base 5 of f of 4 is equal to 1. And now we have 5 to the 1 is equal to f of 4. So f of 4 would equal 5 to the 1 is just 5. And so on this table here, I can put in a 5. Hopefully you see what's about to happen. Now I have log base 5 of f of 5 is equal to 2. So 2 to the second, I lied. 5 to the second is equal to f of 5. F of 5 equals 5 squared, which is 25. So here's 25. And now this last one, I need more space. I have log base 5 of f of 6 is equal to 3. So 5 to the 3. F of 6 is equal to 5 cubed, which hopefully you know is 125. Okay, so what is this graph going to look like? They probably they won't make you graph it, but they might ask you to pick it out from a lineup. So here's 3, 4, 5, 6, and then we're at 1, we're at 5, we're at 25, and we're at 125-ish. Okay, basically the point is it's exponential. Okay, hopefully that was helpful. Let's see, I've got one more problem. And this is the one I might be the shakiest on. Okay, so they're telling us that the number of bacteria in a sample is recorded every day for a week. These data are used to produce a semi-log plot as shown. The function b gives the number of thousands of bacteria in the sample for day t. Write an equation for b of t. Okay, so here is what I see. I see that this is the point 1. And then on this graph, oh y'all, I'm gonna mess this up. Hopefully I won't. Okay, this is at 20, but the way that we graphed this this is log of 20. So this is the point. If I want to make it linear, I need to use log of 20 for that point. Okay, so I think, oh, dang it. Okay, and then this next one becomes this has an x value of 2, and then this is at, I think if we zoomed in, you might want to zoom in on the PDF version. I think this is at log of 80. I do know where I got these values. Oh, that's not an 80, that's an 80. And then I think this is 100, 200, 300, and I think this is 3 comma log of 320. Then this becomes, is that right? Okay. I think this becomes 4 comma log of, well, let's see, hang on just a second. 1280, I think is what that value is. 5, and then 5, 1, 2, 0. Nope, not that. Log of that. Okay, so I'm gonna stop wasting your time. Excuse me. What we might notice here is we can find the average rate of change of this line if we say log of 80 minus log of 20 over 2 minus 1. And so this becomes log of, well, so we can squish, what is that? We can squish subtraction together with division. So 80 over 20, and then that's just equal to 1 on the denominator. This equals log of 4. So my average rate of change among these values is log of 4. This is where I struggle with coming up with the equation of that line. Okay, so now what would the initial amount be? Okay, hang on. So if I say, basically, we want to write this as, this ends up becoming our rate of change, and then we need to find our initial amount. And so if we were here at 20, and then we're multiplying, notice I went 20 to 80 to 320, these were all multiplying by 4. If I come back one and multiply by, divide by 4, I'm at 5. 1, 2, 3, 4. wait, 1, 2, 3, 4, 5, I think is here. And so this ends up, I think what we want here is b of t is equal to 5 times 4 to the t. And you may notice that that was exactly what I plugged in my table to create my different values. So yeah, those were all those points. There is a better way to describe this. I need to go watch my video from last year. I am sorry. I'm going to do the best I can. I mean, we can kind of see where I was getting these numbers and maybe good enough to get you to answer the multiple choice question correctly. Sorry, if I can do better, I'll make another video. All right, like, subscribe, comment, know that I'm human, doing the best I can, and go practice.